Okay, today we're going to talk about arithmetic sequences and common differences. So first, an arithmetic sequence is a bunch of numbers that are separated by commas, and but there's one special thing about them, is that the difference between each term and the previous one remains constant. So what does that mean? So in this example here, we add 2, and then we add 2, and we add 2, and we add 2, and so on. And that, because we're adding a constant number, that makes it arithmetic. So this is arithmetic. And the common difference, which is the amount that we keep adding, we use with the letter D, and so we would say D is equal to 2 because we're adding 2 each time. Okay, and the formula for the common difference is right here. It's equal to the next term minus the previous term. So in this example, if I take the second term, which is 4, minus the previous term, which is 2, then that's going to give me a common difference of 2. Okay, same thing with this one here. Plus 2, plus 2, plus 2, arithmetic. Okay, this is plus 10, this is plus 90, this is not arithmetic. Okay. Here, now in this one here, it's minus 2, minus 2, minus 2. This is arithmetic. And D is equal to negative 2. This one here, D is equal to 2. Here we, let's see, it's plus 0.5, plus 0.5, plus 0.5. So it's arithmetic, and D equals 0.5. Now this one's very interesting, because if you could think of this as 7 over 4, comma 6 over 4, comma 5 over 4, comma 4 over 4. They simplified this fraction right here and this one right here. And if you have the common denominator, you can see, look, we're subtracting 1/4 each time, so D equals minus 1/4, and this is arithmetic. Okay. This one is plus 2, plus 1, plus 3. This is not arithmetic. Okay, now these are, the next few ones here are a very important process. This is the general form simplified. So if we have u subscript 1, which is our first term, that means I plug in 1 for n. So 5 times 1 plus 2 is going to give me 7. If I plug in 2 in for n, I have 5 times 2 plus 2, and that's going to give me 12. If I plug in 3 in for n, we get 5 times 3 plus 2, which gives me 17. Okay. So here we keep adding 5, so this is arithmetic. And D equals 5. Okay, here, if I plug in 1 in for n, a sub 1, we get 3 times 1 plus 1, which gives me 4. If I plug in 2 in for n, we get 3 times 2 plus 1, gives me 7. If I plug in 3 in for n, I get 3 times 3 plus 1, which gives me 10, and so on. So this is arithmetic, and D equals 3. We keep adding 3 each time. Here, B subscript 1, I'm going to have 2 to the power of 1, which equals 2. b subscript 2, 2 to the power of 2, which gives me 4, b subscript 3, 3, 2 to the power of 3, which gives me 8, b to the 4, 2 to the power of 4, which gives me 16. So we are not adding the same amount. So this is not arithmetic. And let me give you the last couple. Here, when we plug in 1, 2, 3, 4, we end up with 3.5, 3, 2.5, 2.0, and we keep subtracting 0.5. So it is arithmetic, and this one is not arithmetic. We plug in 1, 2, 3, and for n, you end up with 1, 4, 9, 16, 25. You might want to hit pause to check your work. Okay. Question 2A, B, and C. So write down the first 5 terms of a sequence in which the difference between each term and the previous term is always 4. Now, in this, you could have started with any number. So I just started with 0, and I kept adding 4. But your sequence could be starting with anything because they didn't tell you. The first 5 terms of a sequence with a common difference of -3. So I just started off with some random number like 30, and we have a common difference of -3, which means it keeps going down by 3. Okay, now this one's a little more specific. The first 4 terms of an arithmetic sequence in which the first term is 2. That means we have to start off with 2. And then the common difference is -0.5. So we keep subtracting 0.5. Okay, and problems like this one are going to be more like what we're going to see in our assignments with this for arithmetic sequences. Okay, so let's look at this here. So the sum of the terms of an arithmetic sequence is called an arithmetic series. So that's when we add all the things in arithmetic sequence together. So which of these is an arithmetic sequence? So here, you know that I'm adding 6, adding 6, adding 6, so that makes this one arithmetic. Okay. On this one here, I'm subtracting 2.5, subtracting a smaller number. I'm not subtracting the same amount, so this one's not arithmetic. Okay? So the common difference can tell us if it's arithmetic or not. Okay, so how can you distinguish arithmetic sequences from other series? Is the arithmetic sequences in series always they either increase or decrease by the same amount for the next term? Okay? Now, let's look at this. Well, we have an arithmetic sequence, and we start off with u sub 1. So, okay. And if I've got my second term, I'm going to have the u sub 1 plus the common difference. And then to get the third one, I'm going to have u sub 1 plus the common difference and plus the common difference again. And then the fourth one, we're going to add the common difference a third time. And the fifth one, we're going to add the common difference a fourth time. And then hopefully you start seeing the pattern that if I wanted to find the sixth one, I would add u sub 1 plus the common difference 5 times. And when you see this, notice that, okay, this is u subscript 5, and here I've got the common difference, and I've added the common difference 4 times. So if this is u subscript 5, and it's going to have 4 minus 4 times 4d, and plus equals u1 equals 4d. You can find that the general formula is going to give you to find any term, you would start off with the first term plus 1 less than whatever the term is. So if I'm trying to find the fifth term, this is going to be 1 less than 5. Okay? So this is the general formula, and you will find this formula in your formula packet, and we'll be using this throughout this lesson. So let me just do the last one on this page, and then we will do the rest of it on a separate packet. Okay, so you know that the first term of a sequence is 5. So find the second term and the third term. So the second term is going to be 5 plus our common difference of 2/3. So the second term is equal to 5 2/3. The third term is going to be 5 2/3 plus another 2/3, which is going to give me 5 4/3, which we can simplify to, so the third term is equal to 6 1/3. Okay? Write down an expression for the nth term. Okay, so using what we said earlier, u sub n equals u sub 1 plus n minus 1 d, where d is the common difference, n is the number of terms, u sub 1 is the first term, so we're going to write this as u subscript n equals 5 plus n minus 1 times 2/3. Okay, so if I'm writing a general expression, I need to have the u sub 1 that's given, and we need to have the common difference, which should be given. So, and that's my general expression. Okay, determine whether or not 49/3 is a term for this sequence. So what we're going to see or determine is 49/3 going to be a term? And we know it is if n comes out to be, if I plug this in and we have n comes out to be an integer. So let's try this out. Because when we're counting numbers in a sequence, you're counting 1, 2, 3, 4, 5, 6 when you count. So if we have n coming out to be not an integer, a positive integer, then we know that it won't be a term in the sequence. Okay, so we just plugged in 49/3 as our final term, and we're going to see if n is an integer to determine whether or not it is a term in the sequence. So one thing I did in the other class, I suggested maybe we could subtract 5 on both sides. And so then I've got hold on a second here. We need a common denominator. And so if I'm going to have a common denominator, let's call this minus 15/3, minus 15/3, right, to make this go away. And 49/3 minus 15/3 is going to give me 34/3. Okay, because we subtracted 15/3 on both sides to make the 5 go away. And now I'm going to multiply both sides of the equal sign by 3/2. Now the reason I'm doing that is I want to have this 2/3 and the 3/2. I want that to cancel out. And now I'm left with, okay, so, and this 3 and this 3 cancels out. So now I've got 34/2. equals n minus 1. Okay, so 34 over 2 equals n minus 1. Well, 34 divided by 2 is 17. And then the final step is we add 1 on both sides, and then we get n equals 18. So, so the answer is yes, that 49 over 3 is a term in the sequence. Okay, and the rest of this video, the rest of this packet I will do in a separate video.